Alright, so today's lesson is over angles. We're going to name, classify, and measure angles, solve problems using the angle addition postulate, as well as the definition of an angle bisector. So I want you to take a minute, pause the video, and write down these definitions on your sheet of paper, on your notes page. Alright, well, we're going to start off talking about an angle. An angle is formed by two rays with a common endpoint. So we learned that rays have an endpoint and then go off in one direction forever and ever. So if I combine two of them together, I have what's called an angle. We always name angles with three letters. So the letter that's always in the middle will be whatever that common endpoint is of the rays. So when I name this, I would name it angle ABC, or I could name it angle CBA, as long as B is the middle letter, because it is the common endpoint of the two rays. The next definition we're going to talk about is the measure of an angle. Angles are measured in degrees. A degree is 1/360th of a complete circle. Well, that's because a complete circle, if I go all the way around, is 360 degrees. So when I'm talking about the measure of an angle, if I were talking about this angle ABC that we kind of talked about before, and say I measured it with my protractor, I could tell that this angle may be somewhere around 30 degrees. We'll do more accurate measurements later, but for now, we can tell the measure's angle from how far it opens up. The next definition we're going to talk about is congruent angles. Congruent angles are angles that have the same measure. So their measures are the same. So if I look at an example, say I have angle, say I call this angle CDE, and this one over here I call GHJ. If I know that this angle is 30 degrees and this angle is 30 degrees, then I know that they're both equal. Their measures are equal. They're congruent. So I can say a couple of things. I can say that the measure of angle CDE is equal to the measure of angle GHJ, or I can say angle CDE is congruent, which means they have the same measure, to angle GHJ. So if we're talking about congruency, we want to make sure we're using this symbol. If we talk about their measures being equal, we use the measures and we use equal sign. So congruent angles, they have the same measure. The next definition we're going to look at is the angle bisector. Now an angle bisector is a ray that divides an angle into two congruent parts. So say I have this big angle, KLM. An angle bisector would go straight through the middle and divide the angle up into two congruent parts. So ray LP would be an angle bisector. Because it divided this angle up into two congruent parts. These measures would be equal. The protractor postulate. It says, given that I have a line AB and a point O on AB. So I have a line AB and I have a point O somewhere on this line. It says all rays that can be drawn from O can be put into a one-to-one correspondence with real numbers from 0 to 180. So that just means if I draw a ray off of here, I can take my protractor, put it on here, and find the measure of this angle. So I can do something like this and say, oh, the measure of this angle is, well, wherever that line would reach out to. All right, let's talk about the classifications of angles. I have 4 different types of angles that we're going to talk about today. The first one is an acute angle, because it's a cute little angle. Acute angles are less than 90 degrees, and they have to be greater than 0 degrees. So they have to be greater than 0 degrees, but less than 90 degrees. The next definition is a right angle. A right angle is exactly 90 degrees. To show that things are right angles, we put a little box inside the angle to show that that's actually a 90-degree angle. The next one is an obtuse angle. An obtuse angle is greater than 90. So it has to be greater than 90 degrees, but less than 180 degrees. Greater than 90, greater than this one, but less than 180. And the last one is a straight angle. A straight angle is formed by opposite rays. And measures 180 degrees. So anytime I have a straight line, a straight angle, that is 180 degrees. So the last thing we're going to talk about definition-wise is the angle addition postulate. So that says that if S is in the interior of angle PQR, then the measure of angle PQS plus the measure of angle SQR is equal to the measure of angle PQR. So it probably doesn't make a lot of sense when you're just reading it, but let's draw a picture of what that looks like. So we started off with angle PQR. I have angle PQR, and it says that S is somewhere in the interior of that. So it says that angle PQS, so angle PQS, this angle right in here, plus angle SQR, so plus this angle right here, is equal to the measure of this whole thing, right? Makes sense. One part plus the other part equals the whole thing. Alright, so let's use some of the stuff on the back page to actually do some problems. So, I know you probably don't have a protractor at home, so you can do this when you get to class. So it says, use a protractor to draw an angle with a measure of 57 degrees and an angle with a measure of 163 degrees. So when I'm drawing angles, I need to start out with a straight line. To use the protractor, I take this line and put it at the end of my line, and then I come up here and find 63 degrees. And it looks like it's somewhere, I see 60 right here, so 63 would be somewhere right here. So I'm going to use my flat edge and kind of start drawing my line to make my angle. And then I'll just finish by taking the protractor off and finishing my line. So this would be 63 degrees. So when you get to class tomorrow, I want you to grab a protractor and find the angle with a measure of 163 degrees. So you'll be drawing, when you get to class tomorrow, or next class, an angle with a measure of 163 degrees. Now let's look at part B. It says, use a scanned example for the problem. Find the measures of AOD, angle COD, angle BOC, and angle BOE. So let's start off with the measure of angle AOD. So AOD means I'm going from A to O to D. So I can tell this angle is going to be bigger than 90 degrees, right? It's quite big. So I'm going to use these inside angles right here, starting at 0 and going all the way around to what looks like 165 degrees. So I can say that the measure of angle AOD is 165 degrees. Let's look at the measure of angle COD. We'll see this line right here doesn't start at 0 like the A does, but I'm going from C to O to D. So I'm looking at this angle right inside here. So if I'm looking at that, I can either use the inside or the outside numbers, whichever one I want to use. I'm going to use the outside. So it's going from 105 down to 15. So I'll have to figure out how many degrees is between 105 and 15. So 105 minus 15 gives me 80 degrees. So the measure of angle COD would be 80 degrees. Let's look at the measure of angle BOC. Going from B to O to C. Now remember, I can either use the inside numbers or the outside numbers. I just like the outside ones because they have the little lines on them. So angle B starts at 140 degrees and goes to 105 degrees. So when I subtract those, I get that the measure of angle BOC is 35 degrees. And the last one that we're going to do is measure of angle BOE. So going from B to O to E. Well, E starts at 0, so I can start from here and go all the way around and see that angle BOE is 140 degrees. So that's how we kind of use our protractor to measure angles. Let's look at part C. It says D is in the interior of ABC. If ABD, the measure of ABD is 37, and the measure of ABC is 84, then find the measure of DBC. Well, this is all great, but what's missing from this question? A picture. So let's draw a picture. It says that I have angle ABC, and D is somewhere in the interior of it. Now it tells me that ABD is 37 degrees, and it tells me that ABC is 84. ABC is 84. So this whole thing right here is 84 degrees. So then it says find the measure of DBC. So I'm looking for this right here. Well, back when we were talking about the angle addition postulate, it says if we add this part plus this part, we should get the whole thing. So that means that 37 degrees plus x degrees, because I'm not sure what this is, we'll call this unknown x, should equal 84 degrees. So then we just need to solve. Subtract 37 from both sides, and I get that x is equal to 47 degrees. So I know that this right here and here is 47 degrees. And I could check that by saying, is 37 plus 47 equal to 84? Well, yeah, it is. So I know that this angle, the measure of angle DBC, is equal to 47 degrees. All right, let's try the last one. The last one says BD bisects ABC. If the measure of angle ABD is equal to 6x plus 3, and the measure of angle DBC is equal to 8x minus 7, find the measure of ABD. So that's great. We have another word problem, but we don't have a picture. So the first thing we need to do is draw a picture. So I start out with angle ABC, and it says that BD, some ray BD, bisects it. And what did we talk about bisects means? Bisects means to cut, it's not how you spell cut, cut in half. So that means whatever this angle is equal is, it also has to be equal to this part. So these two parts are equal. These 2 degrees should be equal. So it says that ABD, this angle in here, is 6x plus 3. And it says that DBC is 8x minus 7. Then it says find the measure of ABD. Well, I know that ABD is 6x plus 3, but I don't know what x is, so I can't find out what the exact measure is. So if I know these two parts are equal, it makes sense that I could probably set them equal to each other, right? So now, using this, I can solve for x.
Good work.
So these two parts are equal to each other. 6x plus 3 equals 8x minus 7. So putting them equal to each other will help me solve for x and eventually plug that back in so I can find the measure of this angle. So I know to solve for x, I have to put my x's on the same side. And then I have to get my numbers on the same side as well. So I have 10 equals 2x. So when I divide by 2, I get that x equals 5. But I'm not finished yet. Up here it doesn't say find x, it says find the measure of angle ABD. So angle ABD is 6 times x plus 3. 6 times x plus 3. Well, I just found out that x is equal to 5. So 6 times 5 plus 3, which tells me that the measure of ABD is equal to 33 degrees. But I also want to check that. This is 33 degrees. Well, what about this side? Is it 33 degrees? Is 8 times 5 minus 7 equal to 33? Well, yeah, it is. 8 times 5 is 40 minus 7 is 33.